to Biostat Squid. In this video, I will share with you some of my top tricks I use to create different types of visualizations in R. And for this tutorial, you will need R or Rstudio preferably. You will need to install these packages if you haven't got them already. And that is it. So if you're ready, let's dive in. Great. Okay, so before we start, just a quick reminder that all my code is uploaded on my website, so feel free to copy the code snippets and adapt them to your own situation or results. Great. So let's start by cleaning our environment, importing the relevant libraries and the dataset we will use for this tutorial. So I'm just setting my project library, which is where I have all my libraries installed. And for now, I'm going to load the tidyverse and or color brewer, which I think we're not going to use, but you might want to use it if you want to edit colors in ggplot. Right, and the data set we're going to use today is the iris dataset. You might have heard of it. It's a test dataset or a sample dataset that's very popular in R. So if we have a quick look, you have the sepal length, sepal width, the petal length and width of different species of flower. So that's what our dataset looks like. It's only for visualization purposes, so we're not really interested in the data itself, but actually how we're going to visualize it. Great. So the first tip I wanted to talk about was ggplot themes. And if you've already been using ggplot for a while to create your plots in R, you've probably already heard of ggplot themes. They're an easy way of modifying how your plot looks overall to make them look more professional and publication ready. So I'll just show you. We'll first create a quick and easy scatter plot using ggplot. Now, this is the general theme or the default theme of ggplot. This is what a ggplot theme looks like by default. So a gray background, white plot grid lines. This is the font size and the legend here on the right. And we can change all of this, right? And we can change it with just one line of code. So with just an additional line of code, we can make our plot look so much nicer just by setting a theme. So for example, here I'm setting theme classic. Now I'll just run this to show you. And this is what our new theme looks like. See, the background grid lines have disappeared and they're just like certain changes to it. We could also try theme dark. For example, this is what theme dark would look like. Anyway, I encourage you to have a look at all the ggplot themes because they're worth it, and you just add that one line of code and they change how your plot looks like in general. And if you don't like something in particular, for example, imagine you want to change the axis text size or the color of the lines or whatever, you can just add those modifications by adding plus theme and then adding your custom line. So for example, here I'm changing the color of the text axis. So that's not the actual title, but the numbers down here. I'm also changing their size. I'm removing the axis line in the y-axis and modifying and changing the legend position to the left. If I now run this, we can see that the numbers in the x-axis are much bigger and blue, the y-axis has disappeared, and the legend is on the left. So the trick is to use a theme you like as base and then modify a couple of things if you need to and if you want your plot to be slightly different to that theme. But you can go one step further and create your own theme with the function theme, right? So for example, you can, I created here the Biostat Squid theme and I edited the size of the plot title, the different color of my grid lines, where I want my legend to be positioned, and if I want actually a box around it. I also edited the color and the line width and even the type of the font in my axis text. So I just run this, and now biostat_squid is a theme object, right? And I can apply it to any plot with just plus biostat theme. So let's see what happens to it. So this is my new theme. So as you can see, I have darker axis lines, bigger axis titles. I have a square around my legend. So yeah, it's quite a cool trick, and you can apply it very easily to your plots, and it's just one line. So what I like to do is actually set my theme at the beginning of my scripts, and then just anytime I have a plot, I just add biostat_squid theme, and it applies my nice theme onto my plot, right? And you could have different themes, of course. Now, imagine you want to apply your theme to all your plots. The best way of doing this is by running theme set and then whichever theme you want, right? So if you write theme set, or if you run theme set, now the theme is set, and for the entirety of this script, you don't need to specify the theme. So this ggplot function, I'm just going to run this, and now I get the biostat_squid theme because the theme has been set. So that's quite a nice trick as well if you want one theme for all your plots and you're very sure that's what you want. And imagine if you wanted to change one thing in particular, you can always do that. So for example, I'm going to make the axis title. Does that exist? There you go. Element text, and I'm going to make the color orange. So if we run this, now the color is orange. So I have my overall biostat_squid thing, but then I can always customize it, right? So yeah, I encourage you to use themes. It's very useful, and they will make your plots look much, much nicer. Right, the second trick I wanted to talk to you about is combining plots. And often for publications or for figures where we want to include, several plots in one, we want to combine plots, right? And there are several ways of doing this in R. Some of the libraries I like to use are cowplot, patchwork, and ggpubr. So they're the ones I'm quickly going to show you today. But feel free, to look a bit more into them and see all the options you have. So let's start with cowplot. We'll just load the library, and now we'll create two plots, right? So we'll create a scatter plot and a bar plot. So P1, if I run P1, this is my scatter plot from before, and P2, this is my bar plot, right? And the way we combine plots with cowplot is by calling plot grid, and then we can just give it the names of our plots. We can also create a list. If you prefer a list of plots, we could also just have a list of plots like this. That also works. And then we can of course specify the number of columns, the number of rows, and the relative heights if we want one plot to be higher than another, or whatever sizes we want. So let's just run this. And this is our plot. So the reason why the first plot looks a bit more squished than the second is because I set the relative heights to be, 2 to 3. So that's an easy way of combining plots into one. We could also make it 2 columns and 1 row. So let's have a look. There you go. If you don't specify the relative widths, then they will be equal, of course. And we can also add labels, which is pretty useful if you want to publish the figure or make it look more professional, I guess. So there you go. Now I have my A and my B to say which subfigure it is. So that's pretty useful as well. So yeah, if you just check out plot grid, you see there's many more arguments you can have a look at. But we'll move on to our second library, which is patchwork. And patchwork is really great when you want to include tables, for example. So here you use the function plot layout, and they have to be separated by plus signs. And with the package grid extra and table grub, so actually the function table grub, I'm just taking a subset of this data set. So this is the subset I'm taking. So from the iris dataset, I'm just taking the first 10 rows and just the first 2 columns, because I don't want a really big data frame. And I can set the widths of, my plots and my table. So maybe the easiest is if I just run this and show you. There you go. And yeah, that is it. This is what it would look like. Then we have the table here and the 2 figures here. So that's quite a nice way of combining it, right? Great. And the third library I wanted to talk to you about is ggpubr, which is also really nice. And I like it because you can set a common legend. So if you have 2 plots that come from the same data set, and they have the same colors and the same groups you want to show, then it might be useful to set the common legend to true. And well, there are many more arguments you can set. Again, if you check ggarrange, that's the function. What happened? Oh, I didn't load the library. Maybe that would be good. There you go. ggarrange. It should work now. So again, you can just specify your plot separated by commas, or just add a plot list, then number of columns, number of rows. You can also give it labels. What else can you do? You can set different ways of aligning these plots. I don't know. There are basically so many different options. Anything you want is possible. So you have to see what's the best way of showing your results, right? So I'll just run this. And this is what it looks like. So this is one common legend because I'm showing the groups are the different species of flower or plants. So I just wanted one common legend for both plots. And here we are. Nice. So the third and last trick I wanted to talk about today is saving plots. So if you're using the export option here in the plots pane of Rstudio, this is probably a very interesting tip for you, because saving plots using code is really easy and it will save you a lot of time, especially when you have to re-export the same figure many times or just changing the name or something. And it's just so much faster with a bit of code. So basically, I'll just show you the general structure to save plots in R. And that's basically first opening a device. So it can be a PNG if that's the format you want your plot in, or, PDF or PNG, whatever. There's many different types, right? So I'm going to open up a PNG file. And as you can see here already, you have to specify the file name, .png, obviously, otherwise it will not save itself correctly. So remember to add the ending. And then all this is optional, right? This is the default width and height, but you can change that. So if you save your image and see it's not wide enough, or you want to make it, higher, taller, or whatever, you can always change it. So for example, I would call this my superplot.png, and then I will just, this is the basic command, right? I'm not going to specify any width, any height or anything. And then I would just print out, this has opened my device, and now I print out my plot. So for example, P1, and then it's very important to shut down your device with dev.off, right? So that shuts off the printing device, because otherwise any plot you keep printing, it will just get printed onto the same device, or I don't know how to really call it. Okay, so this is the general structure. Now, where will this plot be saved? So if we don't specify anything, it will be saved in our current working directory. And if you want to find out where that exactly is, we can just run get working directory. So this is the path or the folder where all our plots will be exported to. If you want a different folder, then you can just specify it in the plot name, in the file name, I should say. So for example, if we want this location, there you go, I'll just copy paste it onto here, and this will be the exact location and the name of the plot, and it will open the device there with this name, and I can print my plot P1 and then shut down the device, right? So that's one way of doing things. Now, what I like to do, since I'm mostly reusing the same directory all the time, instead of copy pasting it, I just set it at the beginning of my script. So I set my output directory at the beginning of my script and give it, or, assign it to a variable, out directory, out there. And now I can use this as my file path whenever I need it. So that's out there, right? And I can use this function to create the folder. So if it doesn't exist, or if it exists already, it will give me a warning. That's why I set show warnings to false. If it doesn't exist, it will not give you a warning. And this is useful in case the directory doesn't exist yet, because if you give it a folder that doesn't exist, or a path that doesn't exist, and then you try and open a device there, it will give you an error. So we always want to make sure that our output directory actually already exists, right? And it will save us time of having to open the file explorer and making or creating that folder manually. So the next thing we can do is, for example, before we move on, I just wanted to show you the file name. I now use this function, paste0, to paste the output directory to the name of my plot. So this is what my file name will be. So I'm just going to print this, and this is the file name I'm going to use, right? Careful, don't use paste, because then there will be a space between them and it won't work. So use paste0, or use paste but set the separator to, no space, basically. And this easily allows me to change the name of my plot, or if I want to change the directory, I can just, or the folder path, I can just quickly change it. So the next thing I wanted to show you is setting the height and the width of my image as a function of the number of rows and number of columns, right? So this is useful when I have a list of plots and I'm playing around with the data, sometimes exporting 10 plots, sometimes 3, sometimes I want them arranged in 6 columns, sometimes I want just 1 column. So by making the height and the width of the image depend on the number of rows and the number of columns, which I can easily change here instead of trying to find within my code where the number, or changing the height and the width all the time manually, I can just, make it depend on the number of columns, the number of rows, and I, avoid the plots to become deformed in a way. So the plots will keep the same ratio and they would look nice, and not squished or too elongated or whatever. So if I now run this, the plot should be saved. So I open the PNG device in this folder here. I printed out the 2 plots I wanted, and I called dev off to shut down my device. So now if I open this, it should be here. There you go. So this is my plot. Nice. So another option for you is if you combine all these things together, all my tips together, and you already arranged a plot, right? In this case, I'm doing it with ggarrange. I'm going to assign this to a combined plot object. And this time, obviously, I only need 1 column and 1 row. So combined plot is actually already two plots put together, right? This is my combined plot. And obviously I just need one column and one row because there's only one plot, which is my combined plot. And I can use the same structure as before, right? I open my PNG device, I save my plot, I can save it as ggplot2 if I want. And now I shut down the device and it should be here, superplot2, and it looks exactly the same. So that's another nice trick. And if you're not very convinced about this, you know, opening the device and closing the device, ggsave is also pretty useful. It allows you to save a ggplot object and you just have to specify the file name. And of course, there are many more arguments. I'm just going to check them out. ggsave. There you go. Why is it not working? There you go. So yeah, the file name. You can also specify if you just want the last plot, you know, the last plot you ran to be saved, but in general you just specify the plot you actually want to be saved. And the device will tell ggplot what kind of file extension you want. So if you want PNG, JPEG, PDF, TIFF, whatever it is, you can set the width and the height of the image in different units as well. Anyway, there's many different arguments. Squidtastic! So that is the end of this video. These are some of my top tips for visualization in R. I hope you found this video useful. If you liked this video and you'd like to see more videos like this one, please let me know in the comments down below. Otherwise, have a great day and see you in the next one.